Population is one of the things, especially as populations get large, like the human population, that can be modeled with a population or the continuous growth formula. So we're going to use the continuous growth formula for population. The population in Vancouver in 1981 was 1.38 million. It has been growing continuously at an average rate of 1.7% per year. Per annum means per year. Find the projected population of Vancouver in 2011 to the nearest tenth of a million. So we know we want to find the amount. We know the initial amount was 1.38 million. The rate is 0.17%, so change that to a decimal, 0.017. And how many years is it? Be 30 years later in 2011? So we put 30 in here. And this is something that we can just type directly into our calculator. $2.29, it says to the nearest tenth of a million. $2.29 rounds to 2.3 million. This question is straightforward. Just plug things into your calculator. No need for logs. Where we need logs is if we start trying to solve for how long, for time. When will the population reach 6 million? So if I plug in, here's my PERT formula. Now I want to solve for time. You don't like those numbers. If we divide both sides by 1.38 million, and we cancel out a bunch of zeros, are you okay with that fraction?
Why don't you solve for the actual number?
You could type that into your calculator and get the actual number. At this point, since the value of e is in the equation, when I take the log of both sides, I'm going to take the natural log. And then what is the natural log of e? It's equal to 1. So we can get t by itself by just dividing by 0.017. Natural log of 600 divided by 138 divided by 0.017. I'm going to check that answer, store as x. Check it back into my original equation, which I had 1.38 million e to the r 0.017. And time is x. Does it equal 6 million? It does. So we know that 86.5 equals t. But what did the question ask us? When will the population reach 6 million? And we got 86.5. How do we deal with that? 86.5 years from 1981. So we would have to figure that out. What is 1981 plus 86.5 years? 2067.5. So we would guess in the year In the year 2067, the population will reach 6 million. So these are our basic population questions where they give us the rate. The more complicated population questions look like this. Population of a herd of gophers was first studied. It was 15,000. 6 years later, it was 18,000. If the population grows continuously, and of course, now you would be given a formula that represents continuous growth. If it grows continuously, how long would it take to triple? So we want to solve for, because the question's asking for how long, we want to solve for t. That's right. But the problem is we also don't have r. So before we can solve for t, in order to solve for t, you would need a value for a value for p, and a value for r. But we don't have r yet. So what makes this question a little bit more complicated is you have to find r first. Is there a way that we could plug things into that formula so the only thing we didn't know was r? Yeah, we do, right? 6 years after the 15,000, it was 18,000. So we could put in, it's going to be 18,000. It started with 15,000. We don't know r, but we know that that happens in 6 years. Again, if you can simplify, it makes sense to do so. Divide both sides by 15,000. And now take the natural log of both sides. You could leave it as 18 over 15. If you wanted to simplify that even further, you could. And when I take the natural log of this side, the 6r is going to come out in front. And of course, the natural log of e is equal to 1. So r is equal to the natural log of 18 over 15, all divided by 6. So we go to our calculator, we type that in. And since that's my r value, I'm going to store it as r. One of the things I like to show in my work, what was our number again? 030. I like to write a bunch of decimal places and then just go dot, dot, dot to say to whoever's looking at my work that I'm keeping all of my decimal places until I'm done. So now we found r first. We can now find t. And the question that students always ask here, if I wanted to triple, do I use the 15,000 or do I use the 18,000? It doesn't matter. Because no matter which one you use, let's say you use the 15,000. Here, I'm doing this in black. Then tripling it would be 45,000. E, we know that r is 0.03 dot, dot, dot times t. If I simplify this equation by dividing by 15,000, I'm going to get 3 on this side, which makes sense because it got tripled. If you use the 18,000 and you tripled it and then you divided, you would get 3 as well. So it doesn't matter which value you use. Now if we take the natural log of both sides, course, natural log of e is equal to 1. So I go to my calculator, and I've got the natural log of 3 divided by, now I've stored it as r, so I could go alpha r to plug that in. It is the last answer I have, so I could also go second answer to get that value. Either way, we find out that t is equal to 36.15. Did it tell us how many decimal places we should round to? No. Is that rounded correctly? Yes. So it'll take about 36 years to triple. Again, it's a word problem, so we should finish it with a statement that answers the question that we were asked for. All right. So these are the most difficult questions because you have to find r first. There's enough information in the question that you have to find r first. Then once you've found r, then you could plug things back in and solve the rest. Anything else interesting about this question or that bothered you? No grammatical errors in this question? There is an error. Does anyone know the error? Okay, well, will it take, would it take? I think that one's okay. The problem here is, this is the wrong word.
Oh, it's hurting, but it should be.
It's not a herd of gophers. It's not a pack of gophers. It's not a bunch or a group of gophers. It's not a murder of gophers, it's a murder of crows. Have you heard of like when you have a group of crows, it's a murder of crows. There is a special animal name for a special group name for each animals. Gophers is? No, it's not a cuddle of gophers. That'd be cute, but I don't know if I'd like to cuddle gophers. It's a colony. Colony of gophers. So, in the next question, the word is right. A group of rhinos is called a crash of rhinos. And we'll look up some other group names, but I'd like you to try this one on your own. All right, so there's the answer for the last one.